Today I'm going to show you how to do real-time data logging with the Arduino. We're not going to use any SD cards. We're just going to go take the raw data straight from the Arduino and put it into Excel. So to show you this, I've written a small program in SwiftForth. We'll be using the Forth programming language. And I created this program earlier, so I'm just going to run it. And what it's going to do is it's going to take data from the Arduino and just put it straight into Excel. And this will just go on forever until I hit the enter key or any key, and it will stop the program. And it's going to output how many things that we did or how many samples that we took. So if that's something you're interested in, stay tuned and I'll show you how it works. For the Arduino code, it's a simple sketch. All I'm doing in the setup part is I'm opening the serial port at a baud rate of 9600. In the loop, I've got a simple piece of code that just basically takes a random number from 0 to 1000. And right here, we're going to print out data equals, and we're going to append this number from 0 to 1000 right here, and a delay of 200 milliseconds. So I'm just going to upload this code. And after it finishes, I'm going to hit Control-Shift-M to bring up the serial monitor. And you can see that we have random data. So the point of this is you can substitute this for anything. This can actually be a temperature sensor, GPS, gyroscope, or pretty much anything. So for just demo purposes, I'm just using this random data. And for the final part, we're going to cover the Forth or SwiftForth part of this code. What you're going to do is you're going to go to optional packages, Win32 samples, and you're going to load up terminal.f. Once you got that, we're going to modify this file. You only have to do this once. So what I'm going to do is actually open this file. And I covered this in another video, but we actually put that on there, terminal.f. So in this code, the only thing you need to modify is you need to add this word right here, public. So when you first open this file, that word's not going to be there. All you need to do is type in public, and then you'll have access to these words that are, in the source code below. So you're going to save that. And what you should have access to is a word called com key. And let me see if I have that here. Yeah, okay. So if you type in that word, you should be able to use it. And in the next part, I'm going to show you the next steps for getting this up and running. So basically the two words that do all the work, that do all the magic, are going to be the word I showed you, com-key, and there's another word, com key. So I can actually test this out and you can see it. We'll just create a do loop. We'll call that word com key. And we'll run this word test. So if we run that word, you notice that we don't really see anything, and that's because we haven't connected to the Arduino. So if you look at my previous video, I showed you how to connect to the Arduino, and basically all you need to do is come down here, load up terminal.f, which we've already done, and the next thing you're going to do is you're going to select your COM port. Now I already know that my COM port is 7, so the Arduino is on COM 7. So all I got to do is type in the baud rate and term COM7, and then I hit enter. And pretty much you can just see the data streaming in from SwiftForth. Now the thing with this is I don't have access to my keyboard. So because the keyboard is busy outputting this data. So the trick to all this is we have to somehow get this data into a buffer and move it to Excel. So that's basically what I'm trying to show you, is that we're trying to bypass this default code that SwiftForth already does for us. So to stop that loop, all you do is hit escape and it should break out of that piece of code that was running over and over again. And I have the code right here, and kind of one of the tricks to be able to use your keyboard while that's outputting is you want to just set this manually. So I'll show you what I mean. Right now I'm not connected to the Arduino, but when I run this code, you're going to see that we are connected and I still have access to my keyboard. But you can see down here that it's changed from COM7 and the baud rate is now 9600. So anytime you want to disconnect from the Arduino, you just type in -com and you'll see that it's inactive. So anytime we want to connect and disconnect from the Arduino, we just run this code right here and we are connected. So now that we're connected to the Arduino, we still have access to the keyboard. I can run that word which we typed out earlier. And I'm just going to run it and see what happens. So as you can see, it grabbed the data and outputted this stuff. And as you can see, I still have access to my keyboard and I'm able to basically do anything. So that's kind of one of the tricks to, just to be able to have more access to SwiftForth's words and to be able to control the Arduino at the same time. The next thing is, how do we connect to Excel using SwiftForth? Well, SwiftForth comes with a built-in thing called DDE client, or Dynamic Data Exchange. And you can actually look this up, and it's just called Dynamic Data Exchange. It used to come with Windows, I believe Excel and Word and all those things have this built in. I think it's deprecated. But just because something is deprecated doesn't mean that you still can't use it. It just means it's probably not being supported. So to actually see this work in action, you go to Optional Packages, Win32 Options, and you're going to select DDE Client. So once you have that, you can actually connect to Excel and you can read and write to cells. So I have the how to set this up right here. Basically, all you need to do is to call this word called server Excel. Just, copy and paste that in. And next thing is you need to have a test file. So you should create an Excel file called, test1.xlsx. And after that, you can basically just type in, see if this will work the first time. So basically, the format is you type in, tel, and then you put it in whatever cell you want. In this case, it's just cell 1. So as you can see up here, our word actually went through. So let me delete that and show you in a better way. Let me kind of wipe that out. So you can see that we can just, type in, we can type in anything to Excel using the DDE client. And finally, I forgot that we have to edit one more file, source file. What you're going to do is you're going to come up to Win32 options, and you're going to come up to sio.f. And what you're going to do is you're going to edit this file. So let me just type that in. And what we're going to do is we're going to add some words, which I've already done here. In this source file, you're going to add these two lines. You're just going to add public and this thing called zero value com handle. So basically what we're going to do is we're going to grab the com handle and we're going to actually use it. So down here is where I put that code. It's in this one called +com. And the code I added is just this line right here. So when you first open this file, it's going to look like this. So all you need to do is just add that piece of code and save it. And everything, should work. You should be able to grab the com handle. And we need this to be able to purge the serial buffer. So that's the final file that you have to edit is sio.f, and just add those two lines. Okay, here's the source code. So we'll just go through it line by line or part by part. So first thing you're going to want to do is you're going to want to connect your Arduino, and then you can basically type in whatever sketch you want. You're going to set your delimiter. In this case, I'm using a colon. You can use an equals, a comma, or anything you want. And then you're going to upload the code to your Arduino. And to verify that this works, just hit Control-Shift-M, and you should see the data just starting to stream in. It's just random data. So you can disconnect from that. And here's the source code. And we're going to go pretty much step by step. Next part, we're going to load up DDE, or I believe, we'll load that client up in Win32 options. Next, we'll load the terminal.f. And if you load this, it automatically loads sio.f because it's a part of that package. And then what you're going to do is you're going to open your Excel file. If I can. Okay, we got that open. So we're just going to copy and paste this. This is basically just going to establish a connection to Excel. So once you do that, you've got a connection. And the next part, I'm going to explain basically how to purge the serial buffer. For this next part, we're going to cover basically this part's called PurgeCom. This is a Win32 API. So this one is pretty important, and anytime you want to clear the serial buffer, you're going to use this Win32 API function call. And basically, if you don't use this, your data will look like it's not changing. So for example, if you have a temperature sensor and you put your finger or a lighter, you put the flame next to the temperature sensor, it'll look like it's not changing at all. And that's because the data you're getting is kind of not caught up yet. So you always want to make sure that you purge the buffer. So what we'll do is we'll just copy and paste this in. And we have the ability now to purge the COM buffer or the serial buffer. And this part right here, we see R1, C1. Basically, we are formatting our strings so that they will be in this format. And after each loop, we're going to have, R2, C1, R3, C1, and so forth. So that's basically what we're trying to accomplish with this code. As anything with Forth, there's always, an easier way, but this is kind of what I came up with. So next, we're going to connect to the Arduino using this code. And this allows us to connect to the Arduino, and we have access to our keyboard. So we can, we have access to, SwiftForth's words, and we can connect and disconnect from it. So after that, we're going to create a buffer of 256 bytes. We're just going to erase it out. And you can see it's zeroed out, which we accomplished with this code right here. And so we got that ready. And this is kind of the part where you can branch off and do your own thing. So I'll show you what I mean. After we load this, you can take a sample from the Arduino, and it'll take a few seconds. And we'll dump 100 bytes, and you can see that our data, which didn't have anything, now has data from the Arduino. So we're now able to capture data, and we can actually take another sample, and it'll take a second, and we can, dump the full, the full buffer, 256. And you can see that we've got different data. So we purged the serial buffer, and we were able to get the latest data. So from here, you can actually branch off and go send this data anywhere. In the other video I did, I showed you how to create a TCP client. You can actually post this data to an API endpoint. You can send this off to the internet, or you can send it, in our case, Excel. So I'll show you how to do that in another video, but for now we'll just cover Excel. And for the final half of this code, we're basically formatting this in a special way. We are capturing everything in between a colon and a new line, which if we pull this up, you can see this. This is actually a new line in hex, and we are capturing just everything in between a colon and the new line. So that's basically how we are parsing the data, is using these 3 or 4 words to accomplish that. And can copy and paste that in. And next, we're going to get the data. So basically, we're going to scan and extract the number. So that word is called get data. And we're going to send that to Excel. So we're going to format it in this special way, which was so basically we have to format it this way in order to send it to Excel. If we don't have it in this format, then that library will not work. So we have to do it this way. So that's what that does. I'm basically just going to copy and paste this. And down here is the final word. And basically that just accomplishes what we were talking about before, is we're formatting it in this special way, and we are incrementing R1 to R2, to R3. So every loop, this is going to increment forever until we hit something on our keyboard, and then that will stop the program. So let me see if this will actually run the first time. And if you get this error, which is pretty common because I didn't do any error checking in this code, all you're going to do is come up here. You're going to copy that. You're going to paste it, and you are going to run that piece of code again. And we'll see if it works this time. And hopefully it will go through. It looks like it's going to go. There it goes. So this code does have a slight bug to it, but this was just for demo purposes. Of course, you can always take this a lot further. You can add a catch and throw to this code in order to make this more automated, and there's a few more things you can do. But if you're interested in more videos, let me know, and thanks for watching.